There's a squirrel outside my window. He's brown, staring at me. Wonder if he's looking for food. Oh, I'm back. This is Mr. Norris again from Norris Teaches Science. And today I present measurements and data. So by the end of this video, your goal is I can explain how measurements and data are taken and analyzed. So you're probably like, what are observations? What's data? All this stuff. So let me get my laser pointer here. All right. So first off, what are observations? They're information that are gathered using your five senses. So your sight, your smell, your hearing, your taste, and your touch. All are really important in science. Your sight, you're going to look at everything you do in science and you're going to make observations. Is it bubbling? Is it fizzing? What color is it? Is it clear? Is it changing color? Stuff like that. Smell, you're going to have to smell stuff. But remember, you don't stick your nose right inside things to smell. You fan or waft the smell towards you. Hearing, you're going to have to hear stuff. Do you hear it fizzing? Do you hear it crackling, popping, or is there no sound coming at all? Taste. Do not taste stuff in labs unless you're told to. You don't want to, eat acid and die or taste something and die. So only taste it when you're told. There are things out there that can just kill you by one taste. And touch, you touch stuff when you're told to touch, but you do have to use your touch sometimes to feel things. There's times when you'll stick your hand in a solution in my class because I told you to, and it's going to feel slimy. And I want you to tell me how it feels other than slimy because I'm already telling you it's going to feel slimy. But there are two main types of observations: qualitative and quantitative. All right, so let's talk about either one. We have qualitative, and I have the L capitalized, and I have quantitative, I have the N capitalized. That's for a reason. It's how I remember these two terms. Qualitative, with the L, is observations you describe using your words and your adjectives. So I have the L there because you use your language skills. Right? So examples are like you have big eyes, big being like an adjective, or the table is brown. Brown talks about the table, so it's an adjective as well. Or awkward, colors, stuff like that. You can see some examples down here. Bubbling. All right. You don't use your language with qualitative observations. Quantitative observations, the reason why the N's capitalized is because quantitative observations use numbers like 6, 30. So the examples here I have are like ladybugs have 6 legs, or there are 30 kids on the bus. If it involves a number, it is quantitative. If it doesn't involve a number, it's qualitative. And you will use both of these in all labs. You have to describe what's going on, and you're going to have to give numbers most likely. There are some labs that you don't use quantitative, and there's some labs that you don't use qualitative, but in here we're probably going to use both of them. Now, opposite of an observation is something called an inference. It's a conclusion you have made based on observations, past experiences, or prior knowledge. The thing about inferences is they change when more observations are made. So let's go through an example. I have right here the observation. The school alarm is going off. We can basically hear the alarm going off. And you could be possible inferences right now are the school is on fire. And I could hear you guys cheering for that. We are having a fire drill, or a student pulled the fire alarm. All those make sense. You probably are like, I can think of like 10 other inferences based off that observation. And that's true. What if I change the observation to the school alarm is going off at 3 a.m.? What could the possible inferences be? Pause the video right now and write down 3 inferences that you think could go from the school alarm is going off at 3 a.m. To me, I would be like, someone's broke in, or there's a fire at the school, or the alarm just misfired. Those are some observations I have. But what observations do you have? Share them with your friends that are also watching this video, hopefully. Now, when we also talk about observations, we talked about quantitative, and how you take quantitative observations is that you take measurements. What are measurements? They are taken during an experiment, and they're quantitative. And there's many different types of measurements out there. So let's talk about a couple. The first 2 we're going to talk about temperature and mass. Temperature, how in sense is how hot or cold an object is. When you guys take physical science or chemistry or something like that, you're going to talk a little bit more about temperature and how you can affect it and everything like that. But right now, we're just going to talk about how hot or cold an object is. Is it hot outside today? Is it cold outside today? I don't know. I haven't stepped outside. Tools, you're going to use a thermometer, and the units degrees Celsius, which is going to be more for any place but America. And I live in America. So we, in America, we use Fahrenheit scale. But scientists also have another scale called the Kelvin scale, and it's a all positive number scale going from 0 up. And a lot of times it's used to talk about temperatures that are really, really, really hot. In other cases, scientists are going to use Celsius. So in science class, we use Celsius, not Fahrenheit. Mass is the amount of matter in an object. The tool is a balance, and we're going to have the units of grams, milligrams, and kilograms. You can kind of see a balance right here. There's a difference between mass and weight. Weight factors in gravity. Mass does not factor in gravity at all. The last 3 types of measurements are length, volume, and density. Length is the distance between 2 points. And you're going to either use a ruler or meter sticks. Quick question. How many meters are in a meter stick? Any guesses? It's 1. A meter stick is 1 meter. And so just take my word for it. Stop arguing with me. All right. Units. We're going to use meters, kilometers or kilometers, millimeters, centimeters. We're going to use the meter side, the centimeter side of a ruler. Volume is amount of space an object takes up. The tools are rulers or graduated cylinders. And the reason why there's 2 different tools here that don't even seem similar is because taking volume depends on what type of object it is. Is it a regular object, irregular object, or liquids? So that's a whole other video that would have talked about that. But in here, in biology class, your biology teacher will help you on taking volume. And the units are centimeters cubed or milliliters. Density, you would have to take the mass and divide by the volume to get it. Its unit is grams per centimeters cubed or grams per milliliters because of the 2 units for volume. You can kind of see in this GIF over here, this one way density works. It determines how things are going to sink or float in water. And once we have all this data, all this quantitative data, we're going to have make graphs. We're going to have tables, we're going to make graphs. And these are visible representations or model of the data you took during the experiment. And inside of a graph, you have x-axis and y-axis. The x-axis is the horizontal axis. And in most cases, you're going to place your independent variable, the thing that you changed, on the x-axis. Your y-axis, which is your vertical axis, is where you're going to place a dependent variable, the result of what you changed. Now, there are 3 types of graphs that we're going to need to talk about. You got line graphs, that's up here, up at the top right. And you're going to use, if it involves time, you're going to use a line graph. A bar graph, the one that says favorite snacks, you're going to use to compare variables. And a circle graph is you're going to show part to whole relationship. You can see that at the bottom right, and it's usually for percentages. So if I'm doing an experiment where I'm seeing how long it takes something to do something, that would be a line graph. If I'm comparing how tall different plants grew over 7 months, I would use a bar graph. Ignore the time part with the month. It was just the total for the different plants. And then if, say, I determined what everyone's favorite ice cream flavor is, I made percents with it, I would use a circle graph. In this class, we're probably going to do mostly line and bar graphs in here. Circle graphs require us to do a lot more in the computer system, and it's really hard to draw by hand. And sometimes I like to make you guys draw those graphs by hand. So we're going to use these. But I really hope, and I hope that I nailed it, and I hope you learned something. This is Mr. Norris, and I am signing off.